ಓಕೆ ಸ್ಟೂಡೆಂಟ್ಸ್, ಇವತ್ತು ನಾವು ಸೆಕೆಂಡ್ ಪಿ ಯು ಸಿ ವೇವ್ ಆಪ್ಟಿಕ್ಸ್ ಈ ಒಂದು ಟಾಪಿಕ್ಸ್ನಲ್ಲಿ ಕೆಲವೊಂದು ಕ್ವಶನ್ಸನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಮೊದಲನೇದಾಗಿ ಎ ಡಬಲ್ ಸ್ಲಿಟ್ interference experiment is carried out in air and the entire arrangement is dipped in water. The fringe width increases, remains unchanged, decreases, fringe pattern disappears. Okay, question nodri puna mattome. A double slit interference experiment is carried out in air. Okay, a double slit experiment is there, and that is performed in air, and after that the entire setup, the entire arrangement is dipped in water. Then what will happens to the fringe width? Students, we know already fringe width means it is denoted by beta. Fringe width beta, first it is there in air, so beta of air, fringe width in air, which is equal to lambda d divided by d. We know already this is lambda in air, and capital D and small d. Capital D and small d we know already, and same thing fringe width in water, beta w equal to lambda w d divided by d. Okay, refracting air to water is the refractive index of air to water, which is equal to c divided by v. In water, this is c velocity, in air it is velocity of light in air, and this is in water it is velocity of light in water it is. Okay, c divided by vw. Okay, this is related to air and this is related to water, and that gives again air to water it is refractive index, and c equal to means f lambda we know already, and same thing v equal to f lambda. This is air, f lambda air divided by f lambda water. Students, frequency does not changes in case of air or in case of water, so the frequency, this f and this f get cancelled, and therefore lambda w equal to wavelength of water, which is equal to lambda air divided by lambda air divided by ANW. Okay students, by observing this lambda w, wavelength of water, which is less than that of wavelength of air. So what will happen, wavelength of water is less than that of wavelength of air means automatically the entire arrangement is dipped in water means fringe width automatically decreases. So the answer is decreases, fringe width decreases. Okay, next question is second question. The fringe width beta of the fringe produced in Young's double slit experiment is. Once again question, the fringe width beta of the fringe produced in Young's double slit experiment is beta equal to lambda divided by d, beta equal to d capital D small d divided by lambda, beta equal to lambda d divided by lambda, beta equal to lambda d divided by lambda. Okay students, we know already just previous question is solved, and beta equal to lambda capital D divided by small d. This is the right answer, because we know expression for fringe width beta equal to lambda d divided by small d. Here small d is the distance between the slits, and capital D is the distance between the source and the slit. Okay students, third question. Young's double slit experiment is carried out. Young's double slit experiment is carried out using two bulbs instead of using two slits and one source. Okay, then what will happen in case of Young's double slit experiment? We know already slits are used and one source is used, but in this question Young's double slit experiment is carried out using two bulbs. Okay, two bulbs are using and the experiment is carrying. Then what will happen is interference fringes will be colored, interference fringes will be elliptical, interference fringes will be dark, no interference pattern will be produced. Okay students, in this case two bulbs are used, this is one bulb and one bulb is used means, and experiment is performing means we know already these two bulbs are not coherent means they are moving in all directions. Here also they are moving in all directions. Okay, light is moving in all directions, Means this is incoherent sources. These two are the incoherent sources. These two bulbs are the incoherent sources. Okay, so two bulbs are not coherent sources. So no interference pattern will be observed. So the right answer is no interference pattern will be observed. Question number 4. Light appears to travel in a straight line. Light appears to travel in a straight line because wavelength of light is very small. Second, frequency of light is very small. Light consists of very small particles. Velocity is different for different colors. So the students, we know already why light travels in a straight line, because the wavelength of light is very small as compared to size of ordinary objects, and also different ordinary objects, and also diffraction is not observed because of a small wavelength. We cannot observe the diffraction phenomena, so that's why the light will appears like a straight line. So the answer is wavelength of light is very small, and frequency of light is very small. Light consists of very small particle. Velocity is different for different particles, because okay students, the wavelength of light is very small, that's why we cannot observe the diffraction phenomenon. So light will see like traveling a straight line. Okay, question number 5. Which of the following phenomena is not common to sound and light waves? Which of the following phenomena is not common to sound and light waves? Okay students, separately we know the properties of sound and also the properties of lights. Okay, interference phenomena, this obeys in both the cases, in case of light also, and in case of sound also. And diffraction is there, this is also this phenomenon occurs in both the cases, so in case of sound and in case of light also. And coherence, this is also same. And polarization is occurs only in case of light, but in case of sound polarization is not there, because the sound waves cannot be polarized because they are longitudinal waves. But light waves are transverse waves, they can be polarized, but sound waves are longitudinal waves, that's why we cannot polarize the sound waves. So the common terms are these three: interference, diffraction and coherence. And not common means it is polarization. So the answer is D, polarization. Question number 6. The dual nature of light is exhibited by. The dual nature means particle nature and wave nature. The dual nature of light is exhibited by diffraction, reflection. Students, one by one we see photoelectric effect, diffraction and photoelectric effect, refraction and interference. Okay students, in previous example we solved interference, diffraction and coherence, or interference, diffraction and refraction. All these phenomena will explain the wave nature of light, but photoelectric effect separately explain the particle nature of light. So the answer is dual nature means in this case diffraction is there, reflection is there. These two will support the phenomenon of will support these two phenomenon will support the wave nature. Photoelectric effect will support the particle nature. Diffraction will support the wave nature, and photoelectric will support the particle nature. So next is refraction is there, wave nature it is, and interference is also wave nature. So the both the dual nature means this is the right answer, diffraction and photoelectric effect. Diffraction phenomena explain the wave nature of light, and photoelectric effect explain the particle nature of light. So the dual nature of light is exhibited by diffraction and photoelectric effect. Okay students, question number 7. A ray of light strikes a glass plate. A ray of light strikes a glass plate at an angle of incidence equal to 60 degree. Right, means angle of incidence is given, that is theta equal to 60 degrees given. If the reflected and refracted rays are perpendicular to each other, okay, perpendicular to each other, then refractive index of glass is, refractive index of glass means n is equal to tan theta p, polarizing angle. And this is equal to tan theta is given, that is 60, and tan 60 is root 3. So the answer is root 3. Next question is question number 8. If the critical angle of a crystal is 45 degree, means critical angle is given, C is given, C equal to 45 degree, then polarizing angle is, okay, options are given: sin inverse of half, cos inverse of half, cos inverse of root 2, tan inverse of root 2. Okay, students, we have tan theta p equal to 1 by sin c. The relation between theta p and sin, c, it is tan theta p equal to 1 divided by sin c value is given, it is 45. Sin 45 is 1 by root 2, means this becomes root 2. So the theta p equal to tan inverse of root 2. Tan inverse of root 2. D is the right answer. Okay, students, question number 9. If a star is moving towards earth, then the lines are shifted towards red, IR, green, blue. Okay, students, when the star is moving towards earth means, what will happen when the star is moving towards earth means apparent wavelength of light decreases, means frequency increases. Wavelength decreases means, apparent wavelength decreases means, the shift will be towards blue color. Okay, towards blue color. Shift lines is towards blue color because of low wavelength, and red is high wavelength. So the answer is D, blue. Okay, students, last question. A diffraction pattern is obtained by using a beam of red light. Diffraction pattern is obtained by using a beam of red light. What will happen if red light is replaced by using blue light? Okay, red light is replaced by blue light means wavelength will be decreases, means automatically band size will be narrowed or crowded. Okay, we'll see what will happen. Bands disappears, not like that. No changes will take place. Changes will take place because it depends upon the wavelength. Red is